Hello everyone. On this video we will continue to study the unit circle and look at what we're calling reference angles. Okay, so if you remember from the last unit circle video, we filled out our unit circle. Okay, so what we're going to do here is now we're going to look at every 30 degrees. Okay, so right now what we're going to do is, well, what I did on another sheet is you get anything circular. I just use this little top, or you can get a compass or whatever else, up to you. But I use that to trace and draw my little circle. Okay. So what we're going to do is we're going to look at it and we're just going to mark every 30 degrees. So we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 200, well, 300, 330, then right back around to 360 degrees. Okay, so all I did was make me a circle, and we're going to kind of study that circle every 30 degrees. Same unit circle. Okay, and the reason we're doing that is to show you that the denominator of your radian measure is actually what is shown above the x-axis. I'll show you what I mean by that. Note the denominator tells you how many sections the portion, I may need a little more room, the portion of the circle above the x-axis is divided into. Okay, so what I mean by that is this. We know that 30 degrees is pi over 6. Okay, now that denominator will tell you exactly how many sections above the, let me kind of block that off, above the x-axis that it's divided into. So if you would have had pi over 12, then you know, okay, above the x-axis it's divided into 12 sections. If you would have had pi over 8, okay, above the x-axis, this would have been divided into 8 sections. Okay, so because we're doing every 30 degrees and we have pi over 6, we know this is divided into 1, 2, 3, 4, 5, 6. And I'll show you how doing that will help you get the unit circle. Okay? Alright, so we have pi over 6. Think about it this way, this is 1 pi over 6. Okay, then going up another 30 degrees, this is 2 pi over 6, which once those two cancel out, it's pi over 3. Then we have 3 pi over 6, so 3 pi over 6. Once you simplify it, that becomes pi over 2, which we know is our 90 degrees. So you have 1 pi over 6, 2 pi over 6, 3 pi over 6. This would be 4 pi over 6. So 4 pi over 6. Let me bring that up a little bit. So this is 4 pi over 6, which means once you simplify it, it would be 2 pi over 3. Then you have 5 pi over 6, which can't be simplified anymore. Then you have 6 pi over 6 once you get here. Now this is the key, because once you hit 6 pi over 6, that's just pi. Okay, so remember, this is always going to be pi over 2. And this is always going to be pi when you start at your initial point. Okay, so we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay, now once you keep going, this becomes 7 pi over 6. This becomes 8 pi. Oh, let me bring that up a little more. 8 pi over 6. Okay, now 8 pi over 6 just becomes 4 pi over 3. We have 9 pi over 6. Bring that up just a smidgen. Okay, so 9 pi over 6, which is 3 pi over 2 once you simplify it. You have 10 pi over 6, which is 5 pi over 3. You have 11 pi over 6, which can't be simplified. And then you have 12 pi over 6. Let me clean that up a little. There we go. 12 pi over 6, which is just 2 pi. Okay, now if we go back to our unit circle that we filled in, and I'll move this in a second, so you'll see, like I said, every 30, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi, oh, skip one, 9 pi over 6, 10 pi over 6, 11 pi over 6, oh, well, I kind of mixed up on my circle, but I'm looking at the screen and looking back and forth, so I skip places. So you can see how it still goes from, like I said, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Okay, got a little mixed up there. Okay, but you can see how every 30, how it counts like that. Like I said, if you would have gotten the top half and cut it into 12 spaces, it would have been 1 pi over 12, 2 pi over 12, 3 pi over 12. You can get all of those. So this way you'll be able to fill that in just by knowing how to count. Okay, so there's always a pattern, and that's really the pattern for it. All right, so let me move this out the way so you can finish writing this if you want to. All right, so what we're going to do is with reference angles is we're going to use that pattern to kind of show how we can get all of these, any angle you have, and be able to identify what it's equal to just by using what's in the first quadrant. All right, I know it might sound a little bit tricky, but once you get a little practice, the hope is that you'll see it's not so bad. All right, so if you're still drawing this, feel free to press pause, but we're going to go ahead and move on with our reference angles. Okay, so what is a reference angle? Or reference angle, reference number. Okay, now with our reference number, it's the shortest distance from the x-axis to the terminal point on the unit circle. The shortest distance from the x-axis and the terminal point on a unit circle. And we're going to denote that with a T and a bar on it. Okay. Now sometimes you may see a Greek letter theta with a bar over it. You may see a t with a bar over it. You can see an x with a bar over it. It doesn't matter. It's just t with a bar over it. Give us our reference number. Okay? Alright, so to kind of give you a visual of what's meant by this, let's go back to our handy dandy graph. Let me go back. There we go. Okay, so we go back to our graph. You'll see, and here we go. The distance, the shortest distance between the x-axis and the terminal point. Okay, so we see here that this is our x-axis. Okay, so let's say if your terminal point was right here. Okay, so instead of going all the way around and finding that angle, what we'll do is we'll use a reference angle or reference number and just find the distance from the x-axis to this point. Okay, so let's say instead of, if we have right here, instead of going around 210 degrees or 7 pi over 6 radians, what we'll do is we'll say, okay, the distance between the x-axis and this point is 30 degrees. Okay, because we're just measuring from the x-axis to here. Okay, so that's 30 degrees. So now we know that 30 degrees will give us this point. So all we have to do is know what quadrant we're looking at, and our reference number will be the same, but they'll change from positive to negative depending on which quadrant. So since we're in quadrant 3, we see that x is negative and y is negative in quadrant 3. These two are the same. The only difference is at that point, they're both negative. Okay, what if we went in quadrant 4, 30 degrees from the x-axis? So if we go in quadrant 4, 30 degrees, you see it's still square root of 3 over 2 and 1/2. The only difference is in quadrant 4, x is positive, y is negative. Same numbers, just the y is negative. So instead of trying to memorize all of these, we just remember what's in this first quadrant. And it makes it so much easier. All right. So let's go ahead and move back to our page here. Okay, so let's take a look at our reference numbers by quadrant. Okay, so we have our x and we have our y-axis. Okay, so we know we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, now in quadrant 1, our reference number t bar is just equal to our regular number. So if we go up 55 degrees, it's, or let's say pi over 3 radians or pi over 4 radians, our reference number is just going to be pi over 4 in quadrant 1, because that's the closest to the x-axis. So if our angle is here, or our terminal point is here, we're only going to go up that far. It's no point in trying to go from this direction over here or from here to over here. We're just going to go right there. So it's going to be equal to each other. Your reference number is going to be equal to your terminal point. Okay. Now in quadrant 2, your reference number t bar is going to equal pi minus your angle. I mean, not your angle, your number t. Okay, so your terminal point, so if you're in quadrant 2, you're going to go from here and up. Okay, now in quadrant 3, your reference number is going to equal t plus pi, or it can equal t minus pi. Okay, it depends on which direction you're coming from. If you're looking for t plus pi, let's say if it, again, it's pi over 4, or let's say it's going over here, your reference number is 45 degrees or pi over 4. Okay, so if you're going from pi to pi over 4, and that's 45 degrees, and that's going to be whatever that is plus your additional pi. Okay, or you can go the other direction and have it minus. It depends on whether or not you want it positive or negative. And in most cases, you want it positive because all of them are positive in quadrant 1. Okay, and in quadrant 4, your reference number is equal to pi minus t. Because remember, when you're going a full circle, that's 2 pi. So this will be the point closest if it's in quadrant 4. So you're going to go back 2 pi minus whatever that number is. All right. So if you are still writing this, feel free to press pause. So now we're going to go ahead and do some examples. So hopefully it'll make everything a little bit clearer. All right, so let's say, for example, find the reference angle or reference number. I don't know why I keep saying angle. Reference number of 2 pi over 3. Or you can't say reference angle, but we're using numbers right now, reference numbers and angles, so we're kind of mixing them up. All right, so what we're going to do is going to kind of give you a visual. Okay, so we'll go ahead and draw our x-axis. We have our x and we have our y. Remember, your denominator will tell you how many sections the portion above the x-axis is going to be cut into. So we can see the portion up here is going to be cut into 3 sections. Okay, so you have, we kind of move this down. Let's say 1. Okay, so you're kind of ignoring this a little bit. And I'm going to redraw that, but we're kind of ignoring it only because just to show you that it's 1, 2, 3 even portions up top. So just because this is here doesn't mean it's in our calculations. Okay, so we have 1 pi over 3, 2 pi over 3, and 3 pi over 3, which is just pi. So this will always be pi. All right. So we can see that 2 pi over 3 is in quadrant 2. So we use the reference angle. Or reference number. T equals, T bar equals pi minus T. Okay, because remember, that's our reference 2, our quadrant 2 reference number formula. Okay, so that's going to mean our T bar will equal pi minus our T is equal to 2 pi over 3. Okay, so we go ahead and do our subtraction. That pi, we can make that 3 pi over 3 just to match our denominators. So 3 pi over 3 minus 2 pi over 3, which will give you pi over 3. Okay, so what this tells us is that 2 pi over 3 has the same x and y value as pi over 3. The only difference is that because it's in quadrant 2, your x is going to be negative and your y is going to be positive, where here they're both going to be positive. All right. Okay. So just to show you what I'm talking about, we'll look at pi over 3 and 2 pi over 3. Okay. So go back to your sheet here. You have pi over 3. Oh, where it is. There's pi over 3, which is 1/2 and square root of 3 over 2. And 2 pi over 3, which is right here, is 1/2 and square root of 3 over 2. The only difference is the x is negative. These two, exactly the same, just a negative 1/2 on that one. So that's why this reference angle can be used for that point. Okay, hopefully it's starting to make a little bit of sense now. All right. So if you're still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so what if we want to find the reference angle of 170 degrees? Okay, now the thing is, now we're using angles. Okay, so instead of pi's, we're going to use the degrees. Okay, so once again, we're going to go ahead and draw our graph where we have our x and our y angle. Okay, now you know this is 0. You go up to here, this is 90 degrees, 180 degrees, 270 degrees, and a full circle brings us back to 360 degrees. Okay, just 9, 18, 27, 36. Count by 9s. Okay, so 170 degrees is in here somewhere. We don't have to be perfect. We just have to know which quadrant. So let's say it's about here somewhere. Okay, so let's say this is 170 degrees. Okay, so we know it's in quadrant 2. So since 170 degrees is in quadrant 2, well, I'll put the Roman numerals just to not have so many numbers flying around. So since it's in quadrant 2, we use the reference angle theta with the bar on it is equal to 180 degrees minus theta. Normally it would be t bar equals pi minus t, but because we're using angles and not just the terminal point or the terminal number, we're just going to use 180 instead of pi. Okay, so that's going to equal 180 degrees minus 170 degrees, since that's our theta. Again, it could be t, it could be theta, same thing. So our reference angle is going to be 10 degrees. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so let's say for this example, we want to find the reference angle of 55 degrees. All right, so this one, again, just to kind of help you visualize, we have our x and we have our y. Okay, again, this is starting at 0. We have 90 degrees, 180 degrees, 270, and a full circle is 360 degrees. So that means 55 is somewhere between what we're starting at 0, between 0 and 90. So 55 could be somewhere around here. Again, doesn't have to be perfect. We just have to know what quadrant. Okay. Now, since 55 degrees is in quadrant 1, our reference angle is just 55 degrees. Because literally, this is the shortest distance from the x-axis to that terminal point. Okay, so since 55 degrees is in quadrant 1, use the reference angle theta bar equals theta, which implies that your theta bar is just equal to 55 degrees. Okay, so when they're in quadrant 1, reference angle's pretty easy to find, okay, because it's the exact same as your terminal point angle. All right, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our next example, which makes it a little trickier. All right, so let's say, for example, you want to use the reference angle to write, let me clean up that G a little bit, cosine of 43 pi over 36 in terms of a positive acute angle in radians. All right, so what that means is that we're going to rewrite this, but with 43 pi over 36, we're going to write that a little bit smaller, where it's not this large of a number. Okay? So, first thing you want to do is find your quadrant. All right, now we're dealing with a pretty big denominator here. We have our x and we have our y. Okay, so here, remember, you're starting at 0, and it's in radians, so we're going to have 1 pi over 2, 2 pi over 2, or just pi, 3 pi over 2, and 4 pi over 2 to kind of complete our little circle. All right, now the reason I showed you how to do all of the numerator things before is that this will help you figure out exactly where that quadrant is without having to divide this into 36 points up or 36 sections up top. Okay, and just look at your pi. That's the thing, is if you just do those 3, you'll be able to figure out exactly where this is, because we know that pi, if our denominator is 36, then this is just 36 pi over 36. Okay. So what do we know about pi over 2? Well, since our denominator is 36, half of 36 is 18, so it's 18 pi over 36. Here you have 3 pi over 2. You match your denominator, basically multiply this by 18 over 18, you'll get 54 pi over 36. Okay, so once again, we're just using that denominator to kind of change those a little bit, just so all of our denominators match what's up here. All right, so we see we have 18 pi over 36, 36 pi over 36, 54 pi over 36. So that means 43 pi over 36 has to be between 36 pi over 36 and 54 pi over 36. So we'll be somewhere in quadrant 3. So 43 pi over 36. See, it's all about matching your denominators for those 3 that you already know. Okay, now what we're going to do is, step 2, is use the proper reference angle. Okay, so once we find our reference angle, we can move on from there. Okay, so find the reference angle, or reference number. Okay, so we know that 43 pi over 36 is in quadrant 3. Since 43 pi over 36 is in quadrant 3, use the reference number, or number or angle, whichever word you want to use. T bar is equal to T minus pi. Excuse me. Okay, so that gives us our reference number is equal to our terminal point, which is T, which is 43 pi over 36, minus pi, which we're going to make 36 pi over 36 to match our denominators. This way we can go ahead and subtract. That means your reference number is equal to 43 minus 36, which is 7. So you have 7 pi over 36. Okay, so we're not done yet. Okay, because even though we know our reference number, we have to find out whether or not it's positive or negative based on the quadrant. That's very important. That's the key. Because if you just go right to this, you're kind of falling short just a smidgen. So because it's in quadrant 3, you have to find out what the actual sign of it will be. So our third step, use the quadrant, or use the known quadrant to find out whether the reference number is positive or negative. Okay, so what does that tell us? Well, that says since 43 pi over 36 is in quadrant 3, we know that x equals, because remember we're looking at cosine right up there. Okay, so we know that x equals cosine of our reference number is negative. Excuse me. Okay, so all in all, what that tells us is that cosine of 43 pi over 36 is going to equal negative cosine of our reference number, which is 7 pi over 6. Okay, so remember, we found our quadrant, we found our reference angle. And what that tells us by this being negative 7 pi over 6 is that if we go this way, if we just keep that up on a straight line, this will be our 7 pi over 6. So cosine of 7 pi over 6 will be equal to cosine of 43 pi over 36, but it will be negative because it's in quadrant 3. That's all it's telling us. Okay, so that's why that quadrant is an important step. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so for our next example, what if we want to find the terminal points determined by, let's say A, let's say t is equal to 5 pi over 6. Say B, t is equal to negative 5 pi over 6. Let me clean that up a little. Equal to negative 5 pi over 6. C, t is equal to 7 pi over 4. And D, t is equal to negative 2 pi over 3. All right. So, starting off for A, we're going to go ahead and draw our XY axis because sometimes it helps just to visualize it. Okay, we have our x-axis and our y-axis. Okay, so we know that 180 degrees, or basically a straight line, is going to equal our pi. Our denominator for A is 6, so that means this is going to be 6 pi over 6. Okay, so we know that this portion up here is pi over 2. Since our denominator is 6, we multiply this by 3 over 3, so that's 3 pi over 2. Okay, so we know that 5 pi of 3 pi over 6, sorry about that. We know that 5 pi over 6 is between 3 pi over 6 and 6 pi over 6, because 5 pi is between 3 pi and 6 pi. So 5 pi over 6 is somewhere over here, and we'll put it there just to have it somewhere, as long as we know the quadrant. Like I said, it doesn't have to be perfect. So let me move that A up a little bit. So let's say this is our 5 pi over 6, somewhere around there. Okay, so we know that it's 5 pi over 6, and it's in quadrant 2. So since t equals 5 pi over 6 is in quadrant 2, we will use the reference number formula. T bar is equal to pi minus t. Okay, so if we want to go ahead and calculate it, remember your denominator is 6, so we'll make that 6 pi over 6 minus your terminal point, which is 5 pi over 6. 6 pi minus 5 pi is 1 pi, or just pi over 6. And that is your reference number. All right. Now, since we're looking for the terminal point, we're not quite done yet. Because remember, we have to find the terminal points. So that means going back to, let me go back a few pages here. In my notes, there we go. I'm going to cover this up just for a second. We're looking for these values here. Which one of those will be represented by our reference number pi over 6? So we see that pi over 6, or t equals pi over 6, is square root of 3 over 2 and 1/2 for your x and y. Okay? So what that tells us is that t equals, or your t reference number, t bar equals pi over 6. As a terminal point of square root of 3 over 2, 1/2. Now, since x is negative and y is positive in quadrant 2, your terminal point, those same two numbers, but you're going to make x negative and y positive. Okay, so your terminal point can be negative square root of 3 over 2 and 1/2. Okay, so this is your answer. So I'll move the check from there to there. Okay, so that's how you find your terminal point. All right, so we're going to go ahead and move on to B. You can kind of separate that a little bit. Okay, so once again, we go ahead and draw a little bit of a graph there. So we have our x and y axis there. So we have our x and we have our y there. Okay, now if you notice, this is negative. You have negative 5 pi over 6. When it's positive, you go counterclockwise. When it's negative, you go clockwise. Okay, so remember you have negative pi over 6, so instead of going pi over 2, pi, 3 pi over 2, 2 pi, we're going to go this way now because it's negative. So this will be our negative pi over 2, and keep going this way, negative pi, then negative 3 pi over 2, and then a complete circle bring us at negative 2 pi. Okay, so remember, when your t is positive, bring that down a smidgen. When your t is positive, you're going this way. When your t is negative, you're going the other way. All right. So now we see that our denominator, t equals negative 5 pi over 6, you have a denominator of 6. So that means, of course, we're going to change those denominators to 6. Okay, so here if we multiply this by 3 over 3, that gives us negative 3 pi over 6. And this gets us negative 6 pi over 6. Excuse me. All right, well, we really don't have to go any further because it's between negative 3 and negative 6 that we will find our negative 5. Okay, so we know negative 5 pi over 6 is somewhere in here. Okay, again, it doesn't have to be perfectly graphed. We just need to know the quadrant. Okay, so we know that t equals negative 5 pi over 6 is in quadrant 3. Now the quadrants are still 1, 2, 3, and 4. Those haven't changed, just the direction that we're going. Okay, so we know if it's in quadrant 3, so our reference number is t bar is equal to pi plus t. Now if you notice, last time we had something in quadrant 3, we had, it could be either t plus or t minus. Pi plus or pi minus t. Okay, the reason is because sometimes it's going to be negative. When you're going negative in this way, you're going to use pi plus. If you're going this way, it's going to be pi minus. Okay, so that's why it could be really either or. It all depends on whether or not your t-value is positive or negative. Okay, so if we go ahead and solve this, pi, we can make that 6 pi over 6. So 6 pi over 6 plus negative 5 pi over 6. Okay, now remember, if we were to use minus here, we would end up with 11 pi over 6, which really just would have made it more complicated. So that's why we use the plus here, because that's just minus. So that's pi over 6, which is your reference number. Okay, now once again, we're not done, because we now have to find out whether your terminal point is going to be positive or negative. Okay, so using our reference number, since our reference number equals pi over 6, and that has a terminal point of square root of 3 over 2, 1/2. We know that x is negative and y is negative in quadrant 3. Yep, I might as well put an and there. This shows that your terminal point for pi over 6 will just have both of those as negative. That negative square root of 3 over 2 and negative 1/2. And that's your terminal point. Okay, so remember, your reference number only gives you a place to start. Let me grab our map here. Okay, it just gives you a place to start. Once you start, you just use your, there we go. Okay, it just gives you a place to start. That's all. Once you do that, you say, okay, that reference number over here is just telling me that, okay, in this quadrant, both of those will be negative. That's all it's doing. All right. Okay, so let's go ahead and continue on the next page because we still have C and D. Okay, so for problem C, we have t equals 7 pi over 6. Oh, nope, 7 pi over 4. Good thing I looked back at it. Okay, so again, just for visuals, go ahead and draw our graph here. Remember, up here you have 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, which is 2 pi. And starting off, it's 0, so 1 full circle is 2 pi. Okay, so since our denominator is 4, pi over 2, we multiply that by 2 over 2, that just makes that 2 pi over 4. Okay, and pi, that makes that 4 pi over 4. Okay, that makes this 6 pi over 4, just to get those matching denominators there. Okay, so we're looking for 7 pi over 4, so we see that if this, and I'll move this over on this side, 6 pi over 4. Okay, so if we go with full circle, 2 pi is 8 pi over 4. So we can see that 7 pi over 4 would be between 6 pi over 4 and 8 pi over 4. So it would be somewhere in here. Okay, so we see there it's in quadrant 4. Okay, so t equals 7 pi over 4 is in quadrant 4. So we use the reference number t bar is equal to 2 pi minus t. Okay, so that's going to equal 2 pi. If we want to get our matching denominators, we can just make that 8 pi over 4. So 2 pi will make that 8 pi over 4 minus our 7 pi over 4, which is pi over 4. Okay, so that gives us our reference number. Okay, now since it's in quadrant 4, we know that we can get our terminal point. So our terminal point equals pi over 4. Well, our reference number equals t equals pi over 4 has a terminal point. Square root of 2 over 2, square root of 2 over 2. Okay, so we know where we're starting with. Now all we have to do is say, okay, which one's positive and which one is negative. Since y is negative and x is positive in quadrant 4, that terminal point, square root of 2, move that up, over 2, square root of 2 over 2, that y is going to be negative. So we just make that one negative. And that's your terminal point. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on because we're kind of running out of room. So we're going to continue this on the next page. We still have problem D. Okay. And that was t equals negative 2 pi over 3. All right, so what I want you to do is I want you to go ahead and press pause and try to work this one out on your own. Excuse me. All right, so I'm assuming you've pressed pause, so let's go ahead and verify your answer. Okay, so again, we're just going to draw our graph just to visualize. We have our x and we have our y. Starting here at 0, we have pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, which is 2 pi. Okay, now we see here our denominator is 3. Okay, and it's also negative. Okay, so we'll be going this direction. Okay, now since it's negative, instead of 3 pi over 2, we're going to be making those negative numbers. So we have negative pi over 2, or better yet, just to make it a little bit clearer, because it's in 3 sections, we're going to cut that into 3 sections. Negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, or just negative pi. Okay, so really, just to kind of clear it up, we don't need those since that t is negative. Alright, so go ahead and erase this one too. There we go. Okay, so we know that negative 2 pi over 3 is in quadrant 3. Okay, t equals negative 2 pi over 3 is in quadrant 3. So the reference number is your t bar is equal to pi plus t. Okay, so that's going to equal, remember, pi, we can make that 3 pi over 3 plus negative 2 pi over 3, which is equal to pi over 3. Remember, that's your reference number. Okay, so we can go by our angle there, and we can see that our reference number equals pi over 3 has a terminal point of 1/2 and square root of 3 over 2. Okay, now we know in quadrant 3, x is negative and y is negative in quadrant 3. That point, both of those become negative. Oh, sorry about that. I'm looking down at the paper and not up at the screen. All right. Okay, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so let's say for this example, what if we wanted to find the angle between 0 degrees and 180 degrees, 360 degrees, sorry about that. 360 degrees, which intersects the unit circle at the point square root of 3 over 2 negative 1/2. Okay, so we're doing this with the assumption that we're not going to look at the unit circle that we filled out. Okay, so let's just assume you don't have that with you. All right, so first you want to do is find the quadrant. Find the quadrant. Okay, now how do we do that? We can see here that x is positive and y is negative. Is positive and y equals negative 1/2 is negative. So where is the x positive and the y negative? Quadrant 4. Okay, so that was pretty painless. Okay, how about our second step? We find theta for that value there. Okay, so for those two positives, we find our angle for the positive coordinates. Okay, so both of those are positive. Square root of 3 over 2 and 1/2. We know that, remember, if you're going up the angle, you have your 1, 0. Remember, you kind of visualize it. You have your point 1, 0. And let me move that over a little bit. So we have 1, 0. Okay. So remember, you have your 30, 60, 90 degrees. So you have your 1 pi over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, and it goes up that way. Well, you'll see that this particular point, when both positive, meet up at 30 degrees. So that goes to theta equals 30 degrees. Okay, because remember, you have your technique that we learned in the first video. So you use that, and you find out that that goes to 30 degrees. So now your third step is you want to find your reference angle. Okay, so in quadrant 4, your reference angle is equal to 360 degrees minus your angle, which means that your reference angle is equal to 360 degrees minus 30 degrees, which is equal to 330 degrees. Okay, so what does this tell us? That 330 degrees intersects the point square root of 3 over 2 negative 1/2. Alright, so hopefully this made a little bit of sense and cleared up unit circles and reference angles, and I will see you on the next video.